All right. Hi, everyone. We'll give it just a little bit while all the participants join us. All right, they're coming in now. We had about 90 folks RSVP for this, so very excited. All right, so again, welcome everyone to another online Learn program. First, I would like to share that we are recording this so we can share it to all those who signed up and couldn't make it to the live program. Also, if you would like to have live closed captioning, you can enable that at the bottom of your Zoom window if you click live transcript and then show subtitles. All right, so I'm Mariah Fogg. I'm the Community Conservation Manager for the Berkshire Natural Resources Council, and I'm joined tonight by Charlotte Hood, our Volunteer and Outreach Assistant, Rich Montone, the Director of Fundraising, as well as our speakers, who you're really here for and will introduce shortly. For those who are unfamiliar, Berkshire Natural Resources Council is a land trust actively working throughout Berkshire County on land conservation, land stewardship, and community engagement. We would like to share before starting this program that it is with gratitude and humility that we acknowledge that we are learning, speaking, and gathering on the ancestral homelands of the Mohican people, who are the indigenous people of this land. Despite tremendous hardship in being forced from here, today their community resides in Wisconsin and is known as the Stockbridge-Muncie community. We pay honor and respect to their ancestors past and present as we commit to building a more inclusive and equitable space for all. To learn more, visit mohican.com. And we ask that you please give thought to the native land that you are zooming in from this evening. And now I'll pass it over to Rich.
Hello, everyone. My name is Rich Montone. I work on fundraising for Berkshire Natural Resources Council. Thank you all for being here this evening for this free program. This free program, other free online programs, free outside programs that we do in real life, and all of the land conservation and wildlife protection, support of farms and farmers, and the free access to all of the Berkshire outdoors that happens through BNRC happens because donors make it so. BNRC is a donor-funded organization. I know that there's many donors in the webinar tonight, so thank you so much for your support. You make all of this possible. And if you would like to make a donation to support everything that we do together through BNRC, I will throw the URL where you can make a gift online into the chat. No expectation, just putting it out there because this is how we make all BNRC things go. So thanks so much for your support. Looking forward to the program. And now I'm going to pass it over to my colleague, Charlotte.
Thank you, Rich. Hi, everyone. I'm just going to start with a basic background on what geology is, not that I am the expert by any means, and why it's relevant to BNRC as an organization. So geology is the science that deals with the Earth's physical structure and substance, its history, and all the interacting processes. Geology is relevant to our everyday lives because it looks at some of the most important issues in society, including energy sources and sustainability, climate change, water management, and mineral resources. Not to mention around here in Massachusetts, geological and the Northeast in general, geological processes have resulted in some incredible outdoor experiences and opportunities. So this evening, we're going to hear from Robert and Johanna Titus, who are experts on the Ice Age glaciers that were instrumental in the formation of the mountains and valleys of this region. Robert and Johanna Titus, respectively, are retired professors of geology and biology. They are best known in the Catskills as popular science writers. They write for 3 regional magazines as well as local newspapers. They are authors of 4 books on Catskills and Hudson Valley geology. The Tituses are frequently invited to present lectures on their research and have been seen on television and heard on the radio. They have a Facebook page, The Catskill Geologist, a blog site, thecatskillgeologist.com, And their email is randjtitus@prodigy.net in case you're interested in contacting them directly. We can send that info in our follow-up tonight. Lastly, we have a dedicated Q&A session at the end of our discussion tonight. So if you have questions as the presentation goes along, just make sure to jot them down so that you remember. So without further delay, take it away, Robert and Johanna.
Okay. And it's not coming up.
Mm-hmm.
There we go.
Okay.
I think.
Is that good?
Yes.
Okay. So, as you were just told, this is just a sample page of some of the things that we do. And we also do between about 20 and 30 presentations, both live and virtual now, thanks to COVID, each year. And we start with a view. And is this the Berkshires? We commonly get this question from people that live in our area in Greene County across the river. It's common for people approaching the Hudson Valley from west to east to see mountains in the distance. And you can see this is a shot heading east on Route 23 in Greene County and identify them as the Berkshires, but they're not. The mountains we see here in the distance are in fact the Taconics, and they tend to hide the Berkshires, which lie behind and more to the east. And here is a map of the region with, then you can see the Taconics, and the sea is the Catskills, where we come from, and the Taconics, and then the Berkshires, and up to the north, the start of the Greens behind them. Both mountain ranges are a result of collisions between tectonic plates between about 450 and 360 million years ago, or during the Silurian and Devonian time periods, with the Taconic orogeny that produced the Taconics occurring earlier than the Acadian orogeny that formed the Acadian Mountains, which are now known as the Berkshires. Both were caused by a subduction of a tectonic plate, or one plate sliding under another, causing the upper plate to rise and producing a line of volcanoes along the collision.
Okay. What a marvelous thing it is. I don't know if Johanna is quite old enough to remember, but I am old enough to remember before we knew where mountains came from. We could take a photo like the one you saw a minute ago, and it was a beautiful image of a mountain range, the Taconic Mountains, and we would stand there as geologists, and somebody would say, how did they get there? And we would have to confess that we did not know. A slide or two later, you saw plate tectonics, and I'm old enough to remember before plate tectonics, but the slide that we showed you was an explanation for where mountains came from. What a privilege it was for me to witness the unfolding of a solution to that problem. Well, let's talk about that problem. You're looking at the planet Earth, perhaps 425 million years ago. We have to have a you are there arrow, don't we? And you are right here on that map as it was so long ago. Off to the east was something called an ocean, but it wasn't the Atlantic Ocean. The Atlantic Ocean did not exist. It was called the Iapetus Ocean. Most people say the Iapetus Sea, ugly word, but it's needed because it was a different ocean. It was a unique ocean to that moment in time. Further to the east is, it's labeled Baltica, but most people would look at this and say, this is Europe. maybe you can make out Norway, Sweden, and Finland right here. This was a continent of Baltica, a continent of Europe. And the remarkable thing is that North America is going east, Baltica is going west, and the Iapetus Sea is being squeezed in between. Something's going to happen. Plate tectonics is going to happen. Let's see. Oops. There we go. That's it. We got it. Okay. Now here is, just maybe 10 or 15 million years later, not hardly much time at all, the two have collided. And with the collision of those two plates, those two geological plates, all of the plate tectonics that we've summarized in that image unfolds. The dark brown areas are the uplift of mountain ranges. The one here in North America consists of the Taconic Mountains that towers over the Hudson Valley here in our New York State. What a wonderful thing has happened. Two continents have approached each other. Two continents have collided with each other. And here's a map view of that collision. The dark brown are the Taconic Mountains. The collision has occurred. These mountains have uplifted. Late at night in geology bars, they debate how tall those mountains got to be. A lot of people think they were 15,000 feet in elevation. Others think they might have been taller than that. But when you're in the bottom of the Hudson Valley, we'd like it if you looked up at the mountains rising to your east, recognize them as being the Taconic Mountains, and in your mind's eye, imagine them being 10, 15,000 feet tall, rising above you. You need to use your imagination, but it's not imaginary. It's just something that really did exist. The tan color west of the Taconic Mountains is labeled alluvial plain. It's a mass of sediment. Those mountains were rising, they were weathering, they were being corroded by chemistry, they were being turned into sediment, and a plain of sediment was deposited just west of those mountains. You can see those sediments. These are the Shungung Mountains, and the Shungung Mountains are composed of sandstone, in this case, a very light-colored sandstone. And those grains of quartz that make up that sand used to be up in your direction in what you would call the Taconic Mountains. The mountains were eroded, the mountains sediments were transported, they were deposited here in New York State. And today they make these beautiful, these picturesque Shungung Mountains. What a wonderful thing. 150 years ago, a geologist would have looked at this, would have said, those are the Shungung Mountains. Somebody would say, how did they get there? And they would shrug their shoulders and, well, they would lie probably and tell a story, maybe fib, and pretend that they knew what they were talking about, but they didn't. Today we can. We look at this and we look east, we look at the tectonics and say that sediment came from there. Oh, maybe 400 million years ago. Now, here's our next map view. In the center, absolute center, here is North America. There is Baltica, Europe. You can see Scandinavia a little better in this image. And now, this is the, I guess we still call this the Iapetus Sea. And approaching it is the continent of Africa, connected to South America, India, Saudi Arabia, Australia. What a marvelous thing. This is a continent you've probably heard of. It's the continent of Gondwanaland, a supercontinent that existed so very long ago. And it is drifting across the surface of our globe, and it is approaching North America. There is going to be another collision between two great geological plates. That collision is going to create another mountain range. This one originally called the Acadian Mountains, but the roots of those mountains are today what you call the Berkshires. and the mountains that you've named your group after. You're looking at a map view. It takes us, about 350 million years into the past, and you're looking at the origins of the Acadian Mountains, which is the same as to say the origin of the Berkshire Mountains. This is your ancestry, you folks there in Western New England. Well, you can hardly see it, but the mountain range is being uplifted by this event. Is there any way we can improve upon that? I don't think there is. That's too bad. Well, it looked good when I was preparing this PowerPoint, and it doesn't look so very good right now. Here's a cross-section view, again, taking us back to those plate tectonics. From the east, Africa is colliding with North America. A great subduction is occurring. The African plate is subducting beneath North America, and that is hoisting up the mountain range that we call the Acadian Mountains and generating a great deal of volcanic activity. Billowing masses of molten rock are working their way upward like hot air balloons through the crust overlying the collision zone. Volcanic eruptions are booming and crashing and occurring throughout your area, Western New England. Billowing masses of black soot is rising from those erupting mountain ranges. The crust is being thrust to the west. Or am I being too dramatic about all of this? A great tectonic event is underway, and it happened right where you are sitting at this very minute. Look up out the window and imagine the mountain range rising above you. What's your elevation? Is it maybe 1,000 feet where you are? Go outside later, look up into the air, 15,000 feet, perhaps even 30,000 feet into the sky above you. There may have once been 5 miles of mountains rising above your home in Western Massachusetts. Think about that for a moment. It's just the most remarkable thing. Well, that rising mountain range, the Acadian Mountains, was subject to chemical weathering. The rocks were dissolved. They were eaten away by acid. They were converted into sediment, mostly sand. And mountain streams tumbling down the western slopes of the Acadian Mountains transported that sand in our direction to where we live. Johanna and I are at this very minute. And there it is, deposited limestone, black shale, brown sandstone, and the red sandstone of a delta, the Catskills Delta. What you're looking at here are the Catskill Mountains as they were back then, perhaps 390 million years ago. So Africa is colliding with North America. The subduction is underway. The mountains where you live are rising. They're weathering, they're eroding, they're turned into sediment. They're pouring into eastern New York State, and they're all building the world, the region of the world where you and I and we live. Well, here's another way to imagine it. Your area, the Berkshires, is here, a substantial mountain range, conceivably as tall as the Himalayas are today. They're weathering, they're eroding. The mountain streams are transporting the sediment to what's called the Catskill Delta. Beyond the Catskill Delta is the Catskill Sea, shallow sea, deeper sea, a deep sea, and then a shallow continental sea. You are right there. This is your world as it was so very long ago. There's another way of looking at the whole thing, the Hudson River. The Taconic Mountains, a little further to the east, would be the Berkshire Mountains. And here are the sediments that poured off of your mountains. There are thousands and thousands of feet of sediment. I think people estimate there are about 3 miles of sediment that make up the Catskills. All of that material came from your Berkshires, which had been earlier your Acadian Mountains. This is where we live, right about there. And we are the Catskill geologists. This is our realm. These are the rocks that we like to write about so very often. There's so much here. It's a marvelous thing for us. And there they are, the Catskill Mountains as painted by Frederick Church from the vicinity of Olana. I'll bet every one of you have been to Olana. Wonderful art, the art of the Hudson River School of Art, and something that's very near and dear to us and we'll be returning to as our talk unfolds. Oh, I get this one too. So now we know. Now we have a kind of an understanding, a better understanding of our region, the Hudson River, the Catskill Mountains, the Taconic and the Berkshire Mountains, all the product of plate tectonics.
Well, let's fast forward about 360 million years to the geologic event that formed most of the scenic geomorphology that we see today. That event was the most recent episode of the Ice Age, beginning about 25,000 years ago and ending with the ice receding in our part of the world about 12,000 years ago. Late in the Ice Age, the passing of the Hudson Valley Glacier sculpted Mount Marina from the northeast to the southwest, and also Church Hill. And that would become the site of Olana, the home of painter Frederick Church. Perched on that hill, it takes advantage of the vistas produced by the passing of the ice. Church took advantage and further enhanced those vistas into what are known as planned views. An architectural feature, and this is the view from the south porch of Olana. And then we have basically the same view that Church painted in the winter. The passing of the ice also created a 10-mile long feature known as the Catskill Front, or the Wall of Manitou. This feature, besides forming the most scenic view of the Hudson Valley and beyond at its apex, also became a common highlight in many of the paintings of the Hudson River School of Art. Thomas Cole's painting, The Bend in the River, painted from the town of Catskill, is a view of Catskill Creek with the Wall of Manitou in the distance. You can hardly see it, but it's there. And Frederick Church's view of the Wall of Manitou from Olana. And we want you to know that we show the art of the Hudson River School to emphasize how the Ice Age geology influenced the culture. Let's take a look at some other Ice Age features that we can find.
Now, golly, you folks own about 60 parcels of land, don't you? You are preserving a great deal of land. I bet you none of you have been on all of them. I don't know if I think we've been on a couple. But from now on, honestly, for the rest of your life, we want you, when you're traveling to your land parcels and when you see bedrock, we want you to be thinking about not just the pretty that's all around you, not just the beautiful landscape that's all around you, but the past. We'd always like you to be, maybe 15,000 years into the past, and we would like you to look for evidence of the Ice Age. Now, it's surely the case that any number of times you've walked across outcroppings of bedrock, and we're betting that any number of times you've walked across things that look just like that. Do you see what's there? Scratches in the bedrock, straight scratches, straight line scratches, passing from where I took the picture off into the distance. We're looking at something that are called glacial striations. When Johanna and I were there, and when we took this photograph, we felt coming from behind us, we're looking west now, we felt coming from the east behind us a glacier. It had come down the Hudson River Valley, risen up the slopes of the Wall of Manitou, overtopped those slopes, and pushed its way westward into something that maybe many of you have been to, North Lake. If you haven't been to North Lake, put it high up on your list for next summer. It's such a beautiful place. It beveled off the bedrock. It polished the bedrock with all of the sand that was beneath the ice. You see how shiny that surface is? Over here, it's pretty shiny. It was transporting cobbles of rock with it, dragging those cobbles across the surface, scratching that bedrock surface. When we're doing a lecture in front of a blackboard, I like to scratch the board with my fingernails and drive people nuts. But it's actually a very good way of imagining what the glacier had done. Right here on the eastern shore of North Lake, there's something here that I bet you've walked upon, but you didn't have a trained eye. You didn't know what to look for, and so you didn't know what to see. Now, here's something else that we'd like you to watch for. It's something else that very possibly you walked right by and didn't notice. These are called glacial chatter marks. It's a little challenging for me to describe what exactly happened here, but this surface was polished by the sand at the bottom of a glacier. There are some glacial striations on the surface here and here, but that glacier was dragging a boulder with it. The boulder was pressed down by the weight of the ice. There might have been 1,000 or 2,000 feet of ice above it. The boulder was being pushed from behind by the motion of the glacier. Pushed from behind, the boulder wanted to move forward. Pressed down from above, it couldn't. The pressure from behind built up higher and higher and higher until suddenly, abruptly, in an instant, it overcame the pressure from above and it leaped forward. And when it came to a halt, it left that big chip in the rock. That is a pencil. So you can see that's a pretty big chip, a semicircular chip. When I'm doing this in a classroom, I ham it up and I go, kapunk, and I would do it a third time, but I can tell you're getting tired of it. That really happened. Maybe 13,000 years ago when a glacier was passing across that surface. With any luck at all, now that you know what to look for, next summer, when you're out hiking on your preserves, you'll suddenly walk across a bedrock outcrop and see just this. Are you taking children? Are you taking grandchildren? You can kneel down, point to what's there, and tell the story of how the glacier passed across that surface and did what it did. What a thrill it is to be able to find something of this sort. What a moment, what an epiphany. If you've never seen something like this before, you surely will, and probably sooner than later. And it will be, I think, genuinely exciting, even thrilling, to recognize what the glacier had done. This is another photograph taken on the east shore of North Lake at North-South Lake Preserve in the eastern Catskills. And right where my foot is, you see these chatter marks. Here's another set of chatter marks. And here are some very big glacial striations. A set that moves from the left to the right, and a second set, you see that right there? At an earlier time, a glacier was moving from the upper left to the lower right, dragging cobbles with it, leaving glacial striations, which were almost erased the next time another glacier came by, that second glacier left chatter marks along with glacial striations. You won't miss these from now on when you pass across them. You probably have missed them in the past. It's something we just plain want you to be watching for when you visit your preserves. Here's something else that you've passed any number of times: boulders. In the past, whenever you've walked past a boulder, you've probably paid no attention to it whatsoever. You might have noticed it, said, that's a nice boulder, especially when it's a setting as picturesque as this one. But from now on, for the rest of your life, we, Johanna and I, want you to always think that when you see a sizable boulder on any of your preserves, it is almost certainly the case that that boulder was brought to where you see it by the ice, by the glacier, carried to where you see it by the movement of the ice, the movement of the southward movement of the glacier, and then left where you see it when the ice melted away. An astonishing, wonderful thing. How far did the glacier get? Well, this picture gives you an answer to that question. This is the New York City area. This is Flushing Meadow. The Hudson River today flows in this direction. These are the Palisades across the river from New York City. So New York City would be right about here. Have you spent much time in New Jersey, northeastern New Jersey? These are the Watchung Mountains of northeastern New Jersey. And this yellow is something called the terminal moraine of the Great Laurentide Glacier. Better described as the Great Laurentide Ice Sheet. It was a glacier that originated in northern Labrador. It formed in northern Labrador. It expanded from northern Labrador, and it moved south in our direction and got exactly this far. What is a terminal moraine? It's an enormous heap of sediment. Clay, silt, sand, gravel, cobbles, boulders, sediment. Sediment pushed and bulldozed forward by the advance of the ice until the ice got as far as it could go. Then the climate melted and the glacier began to retreat to the north. As it retreated to the north, it left water behind, and the moraine formed a dam that dammed the lower Hudson Valley and created Lake Flushing, Lake Hudson, and in this case, Lake Hackensack, along with Lake Passaic. As a glacier is retreating from a region, there are going to be a lot of lakes. Well, how did the glacier retreat back up the Hudson Valley? It's a fun thing to document. It's been something that Johanna and I have done. You drive around and you find these moraines, these ridges of sediment left behind when the glacier had retreated while the climate was warming up, and then advanced as the climate was cooling down again. As you probably know, the climate gets warmer and colder and warmer and colder and warmer and colder. Every time it gets colder, that glacier advanced until the climate stopped getting colder and it started warming up, and then the glacier retreated. Advanced to this moraine, it warmed up, it retreated, it cooled down, it advanced to this moraine. It warmed up, the glacier retreated and cooled down, and advanced to this moraine. And all geologists have to do is drive around and put X's on the map where they find these moraines, and then connect the X's, and they create maps of recessional moraines. A single terminal moraine, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 recessional moraines. You have to train your eye to see these things, but you can do it. And when you see these things, there they are. We're just south of the Red Hook recessional moraine in the town of, or just east of the town of Red Hook. in the Hudson Valley. Sand washed, that's the moraine up on the horizon. The moraine is composed of beautiful hills and dales of sediment. And in front of that moraine is sand that washed out from the moraine. We were exploring in the Red Hook area many years ago now, about 12 years ago. And Johanna said, "Stop, look at that." And we pulled over and we stood looking to the north, seeing the hillocks, the cames and the kettles. Maybe you've heard these terms, the hills and the dales that create a moraine, a recognizable moraine. If you don't have a trained eye, you would notice nothing here. But when you do have a trained eye, you see and recognize the moraine. And then in your mind's eye, in your imagination, you look up here and you see the ice that had once been there. Johanna and I can stand there. We have done it. We've looked to the north and we've seen the glacier that was once there. What a thrill it is to be able to do that, to use your mind's eye and to be able to do that. Now, the glacier continued its melting back to the north. And as it continued that, there was a lake forming behind it. And when the glacier got all the way to the north, there was something very substantial, a big lake that occupied all of the Hudson Valley. It was called Glacial Lake Albany. You folks are way down here. Here's Dutchess County, Columbia County, Rensselaer County. Here's our Greene County. We live right exactly there. And the Hudson Valley was filled with water, filled with a glacial lake. We want you to remember that the next time you're out in the Hudson Valley, because we think you'll have a trained eye, which will allow you to see Glacial Lake Albany, not the lake itself, but the bottom of the lake. We were driving on the thruway one day when Johanna said, "Stop." And we pulled over and she said, "Look at that." And what we saw was flat. And you might think, oh, that's not very exciting. What's interesting about flat? And it becomes so much more interesting when you realize that the bottom of a lake is covered with sediment, and the sediment at the bottom of the lake is flat. We were standing along the New York Thruway. We were looking to the east at a flat surface. We looked about 60 feet up into the air, and we could see passing across us waves of Glacial Lake Albany. We were standing on the edge of the thruway. We were also standing at the bottom of Glacial Lake Albany. We want you to remember this from now on for the rest of your lives. Whenever you're traveling in the Hudson Valley vicinity and you see a flat landscape similar to this, we want you to think about what you're looking about. See yourself standing on the floor of an important lake. Now, what we do, just to confirm this, is we always keep a barbecue skewer in the back of the car. And when we think we're looking at the bottom of the lake, one of us takes the skewer out onto the floor of what we think is the lake and drives it into the ground. If it easily slides into the sediment, then we know those are lake sediments. They're silts and they're clays. And there's no gravel or cobbles in it because there are no gravel or cobbles in a lake bottom. If the barbecue skewer slides into the ground, we stand up, we look around, we see ourselves at the bottom of the lake. So get a barbecue skewer the next chance you can, put it in the back of your car, and watch for a flat surface like this. Run a test, see if you can drive it into the ground. And they say, hot ziggity, those Titus people, they were right. What a wonderful thing it is. It rearranges.
We don't suggest that you stop in the middle of the throughway, though. It might be dangerous.
Not the middle, the middle. The edge is okay. And sometimes they can get mad at you for doing that. But if you get a chance and you see a flat surface, do this. bring the skewer along and see if we weren't right. And it rearranges your sense of reality. It transports us. It transports us. It will transport you from this kind of landscape to the bottom of a lake. What a marvelous thing that is. And there they are, the sediments of Glacial Lake Albany. We took this picture in Saugerties, I believe, at a preserve run by the town of Saugerties. Maybe one of your preserves records a glacial lake. Maybe someday you'll see something just like this.
All those lake deposits, mostly clays, turn out to be the perfect stuff to make bricks. And so from Staten Island up to Hudson and New Baltimore in the north, the river was lined on both sides with brickworks. And this is at Stockport. This is Nuttenhook and the ruins of a brick plant, and Empire Bricks it was called. And this is Ferry and Golden Brickworks in Catskill, and that's a woodcut from long ago. And Hutton Brickyards in Kingston. There were brickyards in a big one in Haverstraw, all up and down on both sides of the river. And it was an industry that began in the earliest days of European occupation and bolstered by the need, especially for New York City, to build fire-resistant buildings, especially after two great fires in 1835 and 1845. They changed the building codes in New York City to make it safer. And so it was an industry that supplied up to 1 billion bricks a year just to New York City alone. And that doesn't include the rest of the world. They supplied bricks all the way down to the Caribbean. And here are a few of the buildings in New York City that are still standing today, made from Hudson Valley bricks. It's a very beautiful building, the Park Avenue Armory in New York City. And my favorite little subway station on Wall Street. Just a few examples of some of the buildings that are still around today, made from Hudson Valley bricks.
Oh, we're back to me again already?
Yeah.
Okay, let's get back to Glacial Lake Albany. I'm showing you this picture again because I want you to be reminded what it looked like. And let's proceed from there. Now, this is work that we're doing currently. We're always researching new pathways for our writing, and we've just begun writing a new book relating the landscape architecture of the Hudson Valley to the sediments of Glacial Lake Albany. This is a diagrammatic view of the Hudson Valley. Right there in the middle, of course, big surprise, is the Hudson River. But under it and left and right of it are the sediments of Glacial Lake Albany. Here's that flat surface, which was the bottom of the lake. And here's something else, a delta. Big surprise. When rivers flowed into Glacial Lake Albany, they deposited the sediments of deltas. So what do we have here? The Hudson River has carved a steep slope, and the delta has left another steep slope. And in the 19th century, when up and down the eastern bank of the Hudson River, any number of beautiful mansions were built, many of them occupied by branches of the Livingston family. So many of those mansions were placed on the edges of steep slopes where they could have views. And Johanna has mentioned the term earlier in her talk, views that are called planned views. The architect, the landscape architect, would design a whole estate so that, as in the case with Frederick Church, everywhere you went, and everywhere you looked, there'd be a pretty image, a landscape image, purposefully designed and integrated into the design of the entire estate. If you lived in this house, you would look out the window, you would look into the Hudson Valley, you would look across the Hudson Valley to the Catskill Mountains, and you would have a marvelous, picturesque, beautiful, breathtaking even view. A vista would be a better word. And we're studying how the lakes, how Lake Albany created that landscape architecture. We don't have time to spend on much of this today, but we would like to. We think this will be a wonderful example. You're looking at a map of Hyde Park. Do you know your way around Hyde Park? Have you driven along the Hyde Park? Maybe you've noticed how flat it is. Perhaps you visited the Roosevelt Estate. Perhaps you visited the Vanderbilt Estate. And if you think about it, in your imagination, in your memory, both of those estates were planted on flat landscapes, flat surfaces. Aha, you've learned something. When you see flat, you're perhaps looking at the bottom of Glacial Lake Albany, but I've fooled you. Instead, you're looking at the surface of the Hyde Park Delta. Huh. How did a delta get there? Well, the answer is Crum Elbow Creek. What a strange name for a stream, Crum Elbow. But it flows from the north to the south and makes a westward turn. It flowed right here into Glacial Albany. This was the shore of Glacial Lake Albany. It carried a great deal of sediment with it. The landscape had just been deglaciated. There were no forests. Erosion picked up all sorts of sand carried by the stream. It was carried into Glacial Lake Albany, and everything yellow in this image is a delta. It's the top of a delta, the Hyde Park Delta. What a remarkable thing it is. And the next time you're visiting Hyde Park, we want you to remember this as you drive through the town. How about you go to the Roosevelt Mansion? Springwood is its name. This picture taken from the top of the Delta. Again, Hyde Park is flat. There it is. There's the flat. There is the Roosevelt Mansion at the top of the Delta. And this is what the slope at the front of the Delta looks like. Huh. Hyde Park, the Roosevelt Mansion is located precisely on the edge of an Ice Age delta. What a marvelous thing it is to understand that. Here's a view taken from the land owned by the Vanderbilt family at the top of the Hyde Park Delta on their property. And we're looking over the edge of that delta, and we're looking at a planned view, an intentionally planned view. They cleared away the forest here so that they could open up this view, which they could see, the Vanderbilts could see when they were walking around their property. This is what we're interested in. People have understood that a great deal of landscape architecture was created in the Hudson Valley, but to this date, very few people, if any, have understood how it was integrated into its Ice Age history. What a wonderful book we're going to be working on. To resume this, what you're looking at is the bottom of the lake and the top of a delta. Claremont. Have you been to Claremont? Of course you have. Claremont occupies the bottom of the lake. Claremont is on a flat surface. Bring your barbecue skewer the next time you go to Claremont. Drive it into the ground. 90% of the places that you go in the Hudson Valley, when you try that, you get about 1 inch and it stops going. It's hit a pebble. It's hit a cobble. It's hit something that's blocked its way, but not here, not at Claremont. You can drive the barbecue skewer easily into the ground. Here's the Hudson River, and the Hudson River has cut this bluff into the landscape, and Claremont is this house built at the edge of that bluff and given this lovely view of the Hudson River. There it is, looking across the Hudson River from Claremont. That is a classic planned view. And the picture was taken from right here. We not only enjoy a planned view, we not only enjoy a picturesque view, but we understand it scientifically. Visit Montgomery Place. It has one of the most beautiful front yards on the planet Earth. It has a circular driveway right about here. It has about as nice a circular driveway as you could possibly imagine. And this gorgeous mansion stands on the floor of Glacial Lake Albany. And now you understand. Here's the view from the other side of the mansion, a planned view. And just as we said for Claremont, this is a planned view that was cut into Glacial Lake Albany by the Hudson River. This is Wilderstein. Wilderstein also stands on the floor of Glacial Lake Albany. If you're lucky, you can walk around Wilderstein and see a few places where you can actually see exposures of the lake sediments. Well, you've probably been to all of these mansions. You've probably visited them all, but the next time you go to any one of them, you're going to know so much more, understand so much more about it. Appreciate the fact that it's the bottom of a lake. And there's the view from Wilderstein, intentionally positioned. They put this bench intentionally at the edge of where the Hudson River is cut into the lake deposits to afford that bench a wonderful view.
Well, no matter where you roam around the Berkshires or on many of the holdings of the council or in the Taconics, the Gunks, the Catskills, we hope you'll come to discover for yourselves some of these Ice Age features that we've shown you today, and to see the wonderful vistas that surround you are indeed a gift of the Ice Age. Thank you.
We thank you so much for visiting us today. And now we'll take any questions you care to ask. We'll try.
Yeah, thank you both so much. I'll share, we do have a question and answer option, so you can input your questions into there. And we do have a small enough group that if you wanted to virtually raise your hand, we can allow you to talk and ask the question yourself. So feel free. Fire away.
Getting the first question is always the hardest.
Yeah, I actually have a question which might get folks going. Actually, I'm sorry, we have 3 raised hands already, so I'll go ahead and let these folks. Yeah. Okay, Mindy, I'm going to have you go first.
Hear me?
Yes.
Great, thank you. This was such an awesome presentation. Thank you. I'm curious about when I'm looking west from the top of the Pittsfield State Forest. There's an amazing overlook that's near where Berry Pond is. If you either hike up or drive up that circuit road, are you familiar with what I'm talking about?
We aren't, no.
You get to the top of Pittsfield State Forest, you're looking west over the Lebanon Valley, and then we see another mountain range off in the distance. It's very close in. It's not the Catskills, it's very close in. And I'm wondering, is that valley also part of what was Lake Albany?
No. Lebanon occupies a separate glacial lake. I'm thinking those mountains you saw off in the distance are, I'm going to guess, I think they're the Rensselaer Plateau. You'd have to get a map out and check that. We spent some time, it's about 10 years ago, in the Lebanon area, and we did find that we could map a glacial lake. I think it's called Glacial Lake Lebanon, for crying out loud. And oh boy, we could probably dig up that article. You see, if we'd known you were going to ask that, we would have read the article. But the answer, I think the best answer to your question is get out there the next time with a barbecue skewer and see if you can drive it into the ground. And I bet you're going to find that it was Glacial Lake Lebanon, surrounded, if I recall correctly, this is an amazing exercise of my memory, by deltas. And if there are deltas, a barbecue skewer would have some trouble going into the ground. Let's just, if I tug on my beard and I look erudite and knowledgeable, I say, why, scientists have interpreted the Lebanon area to be the bottom of a lake. Did that work?
It sounds good to me. Thank you.
With a gray beard, it really helps.
Thank you.
Next.
All right, I'm going to call on you, Howard. Let's see if Howard's still around. I'll give him a couple more seconds. All right, we'll go back to him. All right, Miranda. Oh, wait, I think maybe Howard is on.
Am I on?
Yes, we hear you now.
Perfect. All right. Well, that was interesting. I actually live near New Lebanon, but in Steventown, New York. And where my house is located, you can't put anything through the soil. I mean, it's solid gravel. And what causes that kind of deposit?
You've heard the phrase 2 rocks for every dirt?
Yeah.
Now, here, I'm going to tug on my beard again.
We know all about this.
You want to try this one?
Go ahead.
Okay. This is what's called a ground moraine. The glacier came from the north, moving across the landscape, and it was dirty. The bottom of the glacier was simply dirty. It had picked up all sorts of stuff from the north. Clay, silt, sand, gravel, cobbles, boulders, dead elephants, and forest, everything.
Yeah.
And when it melted, it left all that junk behind on the ground. And it's only we call it, use the word veneer, a veneer of coarse grained sediment that we call a ground moraine. And it makes it so difficult to dig a hole in the ground with a shovel or even a trowel. But that's the answer to the question. It's a ground moraine.
Well, I really appreciate that. You know, it's nice to know what I've got here.
Yeah, it's a horrible thing. We live literally across the street from the bottom of a glacial lake, and we live on the side of a hill on the elevation, which is a ground moraine. And I curse every time I try to plant anything because it's very difficult.
It takes a lot of work.
Yes, yes.
And Howard, you have a wonderful radio voice. If you ever get a chance to go on the radio, you should use it.
Oh, wow. I appreciate that. Thank you so much.
Yeah, thank you. So next, I'm going to go to Miranda. And then we'll go to some of the Q&A questions.
Hi, Robert and Johanna. Thank you for the presentation. That was so awesome. I am actually a geologist, so I have a little bit more of a technical question. I lived in California for the past 8 years and have recently returned to my home of the Berkshires. So this was a wonderful refresher of all of this information. And I got to learn a lot about the Hudson Valley, which, you know, coming from the Berkshires, I was more focused on like our area in particular. And also, Robert, talking about geology can never be too dramatic. I just wanted to throw that out there. But my question is, what evidence do you have to sort of theorize the height of the Acadian Mountains back in the day? Like, are you looking at the sediment thickness or deposition of sort of those alluvial sediments in the Hudson Valley side, or are you using radiological dating? I'm just curious.
Okay, well, I think I can try answering that in two. Historically, geologists have measured the thickness of the sediments that make up the Catskill Mountains, and from appreciating the fact that, if there's 4,000 feet of sediment in the Catskills, how many more thousands of feet of mountain do you have to erode to create that sediment? And so you come up with a number and you multiply it through and you get an estimate. Now, another way of approaching the problem is to realize that the Acadian mountain building event involved the collision of two continental plates. And in today's world, that occurs where India is colliding with Asia. So where India has collided with Asia, you get about 5 miles of mountain, so almost 30,000 feet at Mount Everest. If you use how many thousands of feet of mountain does it take to make 3,000 feet of Catskills, you get an estimate closer to 15,000. So I think there's two schools of thought. One which compares the Catskills to the Andes and makes them about 15,000 feet tall. The other compares them to the Himalayas and makes them 30,000 feet tall. Late at night in geology bars, people debate those numbers. And personally, we like the 30,000 feet, but it's because we're popular science writers and it makes a better story.
Definitely. Awesome. Thank you.
You're most welcome. Thanks for coming, Miranda.
All right, thanks, guys. We have an anonymous question, and they ask, I've heard that the Appalachian Mountain Range is considered one of the oldest mountain ranges currently still around. Is that true?
Yes.
That was hard.
Now, if you've spent much time in what we call the Rocky Mountains, the Cordillera, the Western Mountains of North America, and compared them having spent time in the Appalachians, you're going to, or if you fly over them, you get a chance to fly over them. The Western Mountains are much younger. They're only about 100 million years old. They're taller, they're more jagged. The Eastern Mountains, the Appalachians, however, are about 250 million years old. They've been there so much longer, they've weathered, they've eroded, they're much lower, they're not nearly as tall, they're rounded, they're forested all the way to the top. You know, to the trained eye of a geologist, they just look older, and it's because they are. 100 million years versus 250 million, big difference.
Awesome, thank you. All right, we'll go to one more in the chat. So if Lake Albany is an ancient lake and New York Highway runs through it, did they find any marine fossils?
No.
Up by Champlain?
No. I can't recall much in the way of paleontology in glacial Lake Albany. It was isolated from the ocean, so and it was freshwater, it wasn't saltwater. So it was an unfavorable place. I've never heard of anybody finding even a freshwater shellfish. There are snails and clams that live in freshwater, and I don't recall any ever being found. I can't think of any fish teeth or fish bones found in glacial Lake Albany. It was a cold, desolate, sterile, rotten lake.
But what do they find in glacial lakes? Not necessarily, I don't think ever in glacial Lake Albany itself, but in surrounding glacial lakes like Glacial Lake Wallkill in particular, they find lots and lots of remains of Ice Age mammals like mastodons. So they were deposited along with those sediments and clays that were part of the movement of sediment at the end of the Ice Age.
Don't get Johanna started on mastodons. She'll never quit. She loves mastodons.
That'll have to be a future program, I think.
Yeah, sure. Yeah, I'll let her do it.
Well, thank you for that answer.
Great. We're going to go now to Ginny Akabani. I'm going to allow her to talk. Ginny, are you, oh, wait 1 second. Oh, yeah, Ginny, are you there?
How did the Housatonic River form?
Which river?
Housatonic.
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 Housatonic. You get this one.
Housatonic.
I got the last hard one. You get this
H,
one.
no, I don't have no idea.
Housatonic. You get you no idea?
Nope.
Wow, you don't have a gray bearded tugger. Why scientists think.
No.
I'm afraid neither one of us has enough experience with the Housatonic River to be able to give an intelligent answer to that. Remember, we're on our side of the Hudson. We haven't been down your way very much. So we're winging it as best we can.
He's actually lying to you. He went to Boston College.
Boston University. Which is nowhere near where these people are.
Oh, well.
Mm-hmm.
Same state. The Hudson River, just for your knowledge, is definitely on the other side of the Taconic Mountains, but right a major riverway within the Berkshire Hills, I guess you would say, in the valley. All right, Jenny, so we have some information to look up, share with you. So we do have another question from Ava. I'll go ahead and answer that. This was a great lecture. Could you please repeat when the Berkshires were pushed up before they became sediment towards the Catskills?
Okay. The Berkshires began rising about 390 million years ago. They continued to rise until about 360 million years ago. And all through that time, the higher and higher and higher they got, the more they weathered and the more they eroded and the more sediment that they produced, and that was deposited west of those rising mountains. To see something similar to that today, you would travel to northern India and you would approach the Himalaya mountains. And as you got to the bottom of those mountains, you would be getting to an environment analogous to the Catskills of today, and you would be looking up at mountains analogous to the Acadians of so long ago. And when you see a photo of somebody standing on top of Mount Everest, think about 5 miles beneath that person's boots, and that's where you are right now, sitting right now. 5 miles below the tops of those mountains. Next.
Thank you. I don't think we have any other active questions, so I'll invite folks to continue. We've got them scheduled till 5:30, so we have some more time, but we'll end early if we need to. I was curious, Berkshire marble is a very well-known resource in the area, and I just wondered if you could speak to the formation of marble.
Well, that's much closer to my field than Johanna. Marble used to be limestone before it was marble. Limestone forms on the floor of a shallow tropical sea. If you've been to the Bahamas, you see an absolute classic limestone producing land or sea. And when that kind of limestone is freshly formed, it's packed with fossil shellfish. It's packed with chemically precipitated calcium carbonate. But then, if that same limestone gets involved in a mountain building event, which it did in the Berkshires, it's cooked, it's baked. In the midst of a rising mountain, it's subject to enormous pressures, it's subject to enormous heat, and it's a rock that becomes cooked. It becomes recrystallized. Sadly, all the fossils are destroyed, and all of the mineral material, which is calcium carbonate, is turned into the mineral calcite, which is the composition of marble. You have to be very careful when you hear somebody using the word marble, because most building stones end up being called marble when they in fact really aren't technically marbles. All real marble used to be limestone. All sorts of other rocks are called marble when in fact they aren't. So if somebody says it's a marble, ask them how they know.
Thank you.
And the other answer to your question is 380 million years ago when it was turned into marble.
Wow. Any other questions? I have more.
Go ahead.
I just, are there locations to find fossils in the Catskills or within driving distance of a day's trip from where we are?
Oh boy.
We generally, and this is not to discourage anyone, but generally, if we know of places where there are fossil beds, we tend not to tell people because they tend to go and dig them up and destroy the fossil beds.
That makes sense. I appreciate that.
But having said that,
it's one of those things. I'm old enough that I've been to outcrops as they were 50 years ago, half a century ago, and I've been back and I've seen how much destruction occurs by people who probably have good attitudes towards the environment for the most part, but they don't appreciate what they're doing. When I worked in the Bahamas, we had, starting about half a century ago, there was a magnificent petrified coral reef, which was only ever visited by geology classes, college kids and college professors who didn't appreciate what they were doing. And within about 15 years, that fossil coral reef was badly treated and badly damaged by the very people you would think would be so careful. And so if we told you a good outcrop, we appreciate, we feel that we were telling people who would know well, but that's not always the case. And the other part of the problem is I really couldn't recommend a spot. We've had a hard time finding good, rich fossiliferous locations. There's good fossil hunting in the lower Catskills, but the fossils are kind of spread out thin and far between, and you have to have a good eye for them. So we're going to duck that question, but even if we wanted to answer it, we'd have a tough time.
No, we do find a lot of smaller pieces with fossils in them in the stream beds, like in the Catskill Creek and so on like that. So if you walked along one of the stream beds, you would probably be lucky enough to find something.
Go in August when the stream is dried up and just look very carefully. And I bet you within 10, 15 minutes, you'll find something that's halfway decent. And you can't do any harm to that fossil because it's already been weathered out. You can pick that up, you can bring it home, you can break it with a hammer, anything you want. It's not of any scientific value.
Gotcha. Well, thank you. I appreciate your honesty, and that education goes a long way. All right. Any other questions?
Looks like we have two in the chat or in the Q&A. So I'll go with Dominique because we haven't heard from them yet. Dominique asks, how active is the fault line near us? And should we expect to have more mountain building activity?
Late at night in geology bars, we debate that issue. There's some evidence that there are parts in the central Adirondacks that have been uplifting. But if you get 10 geologists in a single room, you'll get 11 different opinions on that. To the best of my knowledge, there is no active tectonics in the American Northeast currently. I think Johanna and I have debated that.
Rebound.
But that's pretty much over. I don't believe there's any active faults in the Northeast. There's no active volcanics in the Northeast. A big earthquake in the Northeast is a 3.5 or 4 on the Richter scale. And so the answer is there isn't much going on in the Northeast, and nor has been for a long time.
Down south further, there's the Ramapo fault line, which I used to live on. So I know a little bit about it, but and it runs through the Rockland County area and down into northern New Jersey. And there are people again who say, oh, someday this is going to really slip and do some damage, but I don't know.
if you're worried about an earthquake fault, don't. The probability is so remote that there's nothing to be frightened of.
Thank you.
All right, we do have one more. I heard that the Berkshire Mountains have been geologically tied to Morocco. Is this true? Can you explain?
I can give a vague answer. Used to be that North America, Africa, and Europe were part of a supercontinent called Pangaea. And the mountains that we call the Berkshires have their matches in Western England, and I would guess in Morocco. I'm far less knowledgeable. But you can go to places in Wales and see rocks that are almost perfect matches to the Catskills. They are sediments that accumulated on the eastern side of the rising Acadian Mountains. And the match would probably be pretty good. Is it that way in Morocco? I'll take the word of whoever told you that was the case. It sounds very likely. Next.
I believe that might be it for us this evening. I'll just share, I did put input into the chat. The Housatonic Valley Association has some information on geology of the Housatonic River on their website. So we'll send that around.
Mariah, we have been over the years very active with the Woodstock Land Conservancy and fairly active with the Columbia Land Conservancy. We know groups like yours, and we've worked with groups like yours, and we're very happy to work with you, and we appreciate what people like you have been doing. And so Johanna and I are grateful to you for inviting us, and we're grateful to what you people do, and we want you to know that.
Well, thank you so much, and right back at you. We are so thrilled that we were able to host you, and looking forward to that Mastodon program in the future.
Anytime.
So yes, thank you on behalf of all the participants. Thank you to the participants for being here. We will follow up via email and send a recording and some of the resources that were mentioned tonight. We're getting some thank yous in the Q&A, so it's the only way that they can share that at this time on the webinar. So yes, round of applause, and we look forward to seeing that new book.
And we thank you, and have a very nice holiday season.
Okay, thanks.